Hi students, welcome to this section where we discuss about number of factors of a number. Say you are given this question, you need to find the number of factors of 588, and remember, a factor or a divisor is a number that can perfectly divide. Let me write that over here. Perfectly divide the given number, right? And in this case the given number is 588, and with perfectly divide we mean that the remainder after you divide will be 0. So for example, if you divide 588 with 2, right, you will get your answer as 294. All right, and your remainder is equal to 0. All right, now we need to find how many factors 588 has. So let's try to understand how we can approach these type of questions. The first step to solve this type of a question is we need to prime factorize 588. We have already seen how to prime factorize a number. Let's do that over here. All right, so we have prime factorized 588 over here, right? Therefore I can see that these are the prime factors, and I can write 588 as 2 square. You have two 2's, you have two 7's, so into 7 square into 3. All right, now once you have prime factorized the given number and written it in this form, you can find the number of factors in a very easy manner. The number of factors of 588 is nothing but, over here you have 2, right, the power 2, so you need to add 1 to that. That's 2 plus 1, and over here you have 2, so that's into 2 plus 1, and over here it's equivalent to writing a 1 over here, so you have to multiply it with 1 plus 1. All right, now this is equal to 3 into 3 into 2, which is equal to 18. So this means that there are 18 factors for 588. All right, now why does this work? This is also an application of permutation and combination. If you have two similar items, right, two similar items, over here it's two 2's, you can take 0 or more items in 2 plus 1 ways, right? That's what we are doing over here. So you have two 2's, let me write it as 2's so that we'll be able to distinguish it. You have two 2's because you have 2 to the power 2 over here. You can either take 0 2's, 1 2 or 2 2's when you make a factor. So these are the three ways. That's why we are doing 2 plus 1 over here. Similarly over here you have only 1 3, so either you can take 0 3's or 1 3's. These are the two ways. That's why you have 1 plus 1 over here, which is your 2 over here. All right, so let me make some space. Let's quickly revise how to find the number of factors of any given number. All right, so I've made some space over here. You need to prime factorize the given number. That's your step 1. After that you need to write it like this, right? And you need to check the powers and add every power with 1 and multiply them among themselves. So for example, if you have a number that is prime factorized as 5 square into 7 cube into say 11. So say this is your number that, and you have prime factorized it and you got this. Now if you want to find the number of factors of this number, over here your power is 2, over here your power is 3, and over here your power is 1. So you need to add each power with 1 and multiply them among themselves. So that would be 2 plus 1 into 3 plus 1 into 1 plus 1. So this is equal to 3 into 4 into 2, which is equal to 24. So this number over here will have 24 factors. In this section, let's analyze questions of the reverse nature. Say you are given already the number of factors. So over here, for example, in the question, it's mentioned that the number should have 3 factors and we need to find the number. So earlier we have seen, say we are given the number 588 and we have found how many factors it has, right? There are 18 factors for 588. All right. Now this question is of the reverse nature. For example, over here it's mentioned the number should have only 3 factors and we have to find the number. All right, let's see how we deal with this type of questions. Let's try to do this question, and over here we are analyzing 3 factors in a future video we'll check what should be done in case it's mentioned odd number of factors. All right, let's do that later. Let's move on now. A given number n to have only 3 factors, n should be of the form p square, where p is a prime number, right? If n can be prime factorized only as p square, then the number of factors will be this 2 plus 1, right, which is equal to 3. All right, let's take an example. Say you have 25, which is equal to 5 square. You can see it has only 3 factors. What are the 3 factors of 25? 1, 5 and 25, right? And remember, 25 is of the form 5 square. And we have seen in this case the number of factors will be 2 plus 1, which is equal to 3, and these are the 3 factors of 25. All right, therefore this question is all about finding prime numbers up to 31, right? Why is that so? We need to find numbers of the form p square, right? We need to find numbers of the form p square, and the condition is n should be less than 1000, so it should not go above 1000. Now if we take 31 square, we know 31 square is equal to 961. So if you take a prime number greater than 31, and if you take the square, you will get a number greater than 1000. That's why the answer is finding the prime numbers up to 31, right? As 31 square is 961. Now say, why is that? What is 37 square, which is the next prime? It's 1369. You can see it's above 1000. That's why we limit it up to 31. Which are the primes up to 31? It's 2, 3, 5, 7, 11, 13, 17, 19, 23, 29 and 31, right? Therefore, you can see that 2 square, that's 4. Let me write that over here. 4, 3 square is 9, 5 square is 25, etc., right? Up to 961. These are the numbers which will have only 3 factors, and these numbers are less than 1000. Therefore, let's quickly revise. In any question, if you want to find numbers which have exactly 3 factors, then that number should be of the form any prime number to the power 2, right? For example, 25 is 5 square, or 121 is 11 square. All these numbers will have only 3 factors. All right, and we have seen that the answer to this question is primes up to 31 to the power 2. So we have over here 11 numbers. Therefore, the answer to this question is 11. Let's do this question. How many natural numbers less than 1000 will have odd number of factors? All right, we have already seen that prime squares will have 3 factors, right? We have seen that in the case of 5 square, we have seen it has 3 factors. That's 2 plus 1, which is 3, right? Now over here we are trying to analyze cases where there will be odd number of factors. Now you can see that if you take any square number, it will have odd number of factors. Now let's try to analyze the reason for this. Now say 36. 36 we know is equal to 6 square, right? It's a square number. Now when we prime factorize 36, we'll get it as 2 square into 3 square. Now you can see that for any square number, the powers that you get over here will be of the form even, right? It will be an even power over here. Why do I say even? You could also have a square number of the form 2 to the power 4 into 3 square. This is also a square number, right? This is nothing but 36 into 4. That's 144. We know this is 12 square, and if you factorize, prime factorize 144, that would be 2 to the power 4 into 3 square. Over here also you can see that the powers of these prime numbers are even. And over here, let's take this case over here. You will have the number of factors as 2 plus 1 into 2 plus 1, which is 3 into 3, or you can think of it as an odd number multiplied with an odd number. And this will give you an odd number as the answer. Whenever you multiply an odd number with an odd number, your answer will be odd, right? Say for example 3 into 7, that's 21, it's odd. Or 9 into 11, that's 99, it's odd. So whenever you multiply two odd numbers, your answer also will be odd. All right, let me make some space over here. Now this was a specific example. Let me write it in a generic manner. Any square number will be of the form n is equal to x to the power even into y to the power even, right? I'm just writing it as e and e dash, and I've just taken two prime numbers x and y. In this case it could be 3 or 4 or any number, but the point is these powers will be even. Now therefore when you find the number of factors, it will be some even number plus 1 into some even number plus 1, and this could have one more also, right? Could be again one more. You could have e double dash plus 1, that's also again odd. So all these are odd. Even plus 1 will give you an odd number. This also is even plus odd, it will give you an odd number. This also is even plus odd, it will give you an odd number. And when you multiply odd numbers, you will get an odd number. Therefore we have seen that when you want to get odd number of factors, you need to take square numbers. All right, let's come back to our question. Now we are given here that the natural numbers should be less than 1000. Therefore the question is, we just need to find square numbers that are less than 1000, right? And we know 31 square is 961. Therefore we just need to find squares up to 31. That's the answer. So 1 square, 2 square, etc. up to 31 square, that's the answer. And you have 31 such numbers, right? 1 2 3 up to 31, that's 31 such numbers. Why did we stop at 31? Let's try to take 32 square. We know how to do that very fast. There will be 3 places. This place will be filled by 2 square, which is 4, right? And then you need to multiply 3 into 2 into 2, that's 12. So you write 2 over here, 1 gets carry forwarded, and 3 square is 9 plus 1 is 10. So you can see that it's greater than 1000. That's why we stop at 31, and the answer is 31. Let's do this question. A room has 1000 lights, right? And 1000 children enter the room one after the other. Now child 1 switches on every light. Child 2 changes the state between on and off for 2 4 6 8. These are the lights which child 2 will change the state, right? Now child 3 changes the state for lights 3 6 9 12 etc. Child 4 changes the state for the lights 4 12 4 8 12 16 etc. Now it goes on like that, and after everyone passes through, we have to find which lights are on. Now pause the video, give it a try, and then we'll solve it together. All right, we are back. I hope you have given it a try. Let's do it together. Now to solve this, let's take any light and see what happens to that light. For example, let's take light 10. Now we can see that child 1 will switch it on, right? All right. Similarly, you can see child 2 will switch it off, right? Because it will be there in this series. All right. Now child 1 will switch it on, child 2 will switch it off. What about child 3? 3 will not touch light 10, right? Because it's not in this series, right? In a similar manner, you can see that this is what will happen with light 10. We have seen child 1 switches it on. Similarly, child 2 switches it off because it will be part of this series. Child 3 and child 4 does not touch it because it's not part of 3 6 9 12. 10 does not come over here, right? Similarly, 10 does not come in this series, so they don't touch the lamp number 10, right? The light number 10. Child 5 will switch it on because it's there in the series. 6 7 8 9 will not touch it, right? Because 10 is not coming in this series. Over here child 6 will only touch lights 6 12 18 etc, and 10 is not there. Similarly, in the case of 7, it will be 7 14 21 etc. 10 is not there. In the case of 8, it will be 8 16 etc. In the case of 9, it will be 9 18 etc. So these children do not touch light number 10, right? And you can see light child number 10 will switch it off because it was on over here, so they'll change it to off over here. Now let's try to analyze this and derive a pattern out of this. We can see that because 10 over here, we have taken 10, right? 10 has an even number of factors, that's why it ends up off. right? What's the number of factors of 10? 10 is equal to 2 into 5, right? So that's the power of 1 and 1 over here. So the number of factors of 10 is 1 plus 1, that's 2, into 1 plus 1, that's 2, which is equal to 4. So the number of factors of 10 is 4. Therefore 1, 2, 3 and 4. You can see that 4 times this light is touched, right? The first time it's made on, the second time it's made off, the third time it's made on, and the fourth time it's made off. Therefore we can summarize that if any number has an even number of factors, it will end up off, right? Say you have a number that has 6 factors, so it will be on, then it will be off, then it will be on, then it will be off, then it will be on, and then it will be off. So it will occur in 6 series. So 6 children will touch that lamp which has a number which has 6 factors, and it will end up off. So we can summarize, any number which has an even number of factors, that light will be off at the end of this process. All right, let's write that over here. We have it over here. This is what we have learned so far. Now if any number has an odd number of factors, it will end up on, right? Let's take an example. We know 5 square is equal to 25, and this over here has 2 plus 1, that is equal to 3 factors. So in the first case it will be on, so 3 times 3 children will touch it, right? So the first case it will be on, later it will be changed to off, and then it will be turned back on, so it will stay on. So we can see if a number has odd number of factors, it will remain on. What are the factors of 25? It's 1, 5 and 25, right? So child number 1 will turn it on, child number 5 will turn it off, and child number 25 will turn it on, right? All right, so let me make some space over here. So far we have learned that lamps which have a number which has an even number of factors will be off at the end of this process, and lamps which have a number which has an odd number of factors will remain on after all the 1000 children have passed through the room, right? Now which are the numbers that have an odd number of factors? We have seen that square numbers have odd number of factors, right? Square numbers have odd number of factors. So the question is all about finding the square numbers up to 1000, and we know that 1, 4, 9, 16 etc. up to 961, which 961 is equal to 31 square. These are the square numbers up to 1000. We have seen that because 32 square will be greater than 1000, right? So 1, this is 1 square, this is 2 square, this is 3 square, up to 31 square. So you have 1, 2, 3 up to 31 over here. That's 31 numbers. Therefore which lights are on? These are the lights that will be on. Light number 1, light number 4, light number 9, light number 16, light number 25 etc. up to light number 961. These are the 31 lights that will remain on at the end of this process. Let's do this question. What is the number of even factors of 36,000 which are divisible by 9 but not by 36? Alright, pause the video, give it a try, and then we'll do it together. Alright, we are back. I hope you have given it a try. Now the first step to solve this question is we need to prime factorize 36,000. Now when you do that, you will get that 36,000 is equal to 2 to the power 5 into 3 to the power 2 into 5 cube. Now when it comes to prime factorization, you know how to do it. So we write the number over here and we keep taking out prime numbers, right? So I can take out 2, that will leave me with 18,000 over here. I can take out 2, that would leave me with 9,000 over here, right? I can take out 5 if I want, that would leave me with 1,800, and it goes on like that, right? So this is right. If you do that, you will get these numbers and you can write it in this manner. Now you could also take it like this. Say you know that you have 3 zeros over here, right? So let me show you a quicker method. You have 3 zeros over here, so that's 10 into 10 into 10, right? These 3 zeros, and we know 10 is equal to 2 into 5, right? So I can just write, instead of 10 into 10 into 10, in my mind I can write it as 2 cube into 5 cube. So this part is taken care, and you are just left with 36. Now 36 is 9 into 4, and 9 is nothing but 3 square and 4 is 2 square. So you just need to multiply 3 square, 2 square, 2 cube and 5 cube. So 3 square is your 3 square, that's over here. 2 square into 2 cube, this will give you 2 to the power 5, that's what you have over here, and you have 5 cube, that's your 5 cube over here. All right, now that was just a quick side note on how you can do the prime factorization in a faster manner, right? Now let's move on. Once you have prime factorized 36,000, let's see how to approach this question. So I've written the prime factorization over here. Now it's mentioned in the question that we need to find the number of even factors, and those factors have to be divisible by 9, and those factors should not be divisible by 36. So let me write these three conditions over here. The factors have to be even, divisible by 9, and not divisible by 36. Alright, now because the factors has to be even, the factor should have at least 1 2, right? At least 1 2 should be taken into consideration when we make the factor. That is, it should not be an odd factor, right? Now it should be divisible by 9, therefore we have to take both the 3's, right? We have 2 3's available, we have to take both the 3's, because only then it will be divisible by 9, right? If you take both the 3's, you're getting 9, and 9 into any multiple, 9 into 2 or 9 into 5 or 9 into 4, any of these will be divisible by 9, and therefore we have to take both the 3's, and it's mentioned it should not be divisible by 36, right? Therefore we should only take 1 2, because if we have taken already both 3's, and if we have at least 2 2's, it will be 9, that's 2 3's, and if you have 2 2's, that would be 4, and then whatever you multiply this with, it will be divisible by 36, right? Because 9 into 4 is 36. As it's mentioned over here that it should not be divisible by 36, therefore we should only take 1 2, right? Alright, now let me make some space over here. Therefore we can conclude that we have only one way of choosing 2's, that is, we have to choose only 1 2, that is one way of doing it. We have one way of choosing 3's, right? Because we have to choose both the 3's, right? And we have 3 plus 1, 4 ways of choosing 5's, right? So basically when we make factors, we can choose 2's, 3's and 5's. We have seen that in when we learned about the number of factors. So if I did not have any condition, if I wanted to find the number of factors of 36,000, it will depend on how many 2's I can choose, how many 3's I can choose, and how many 5's I can choose, right? And we have seen because I have 5 2's, I can choose 5 plus 1, that is 6 ways I can choose 0 or more than 0 number of 2's, right? Now that's when we just had no condition, but in this case we have these extra 3 conditions. Therefore I have only one way of choosing 2's, only one way of choosing 3's. That one way is I have to take both the 3's. This one way over here is I have to choose only 1 2, right? And I have no condition on 5. There's no restriction on the number of 5's I choose based on these given conditions. Therefore I can choose 0 or more 5's. That's 3 plus 1 way of choosing 5's, which is equal to 4. Therefore the number of factors that I can make is 1 into 1 into 4. That is, there are 4 such factors. Let's try to write these 4 factors. So I know that I have to choose 1 2 and 2 3's, right? So that's 2 into 3 square. So this part is fixed. I can either choose no 5, so I'm just leaving it at this place. That's factor number 1. Then second one would be 2 into 3 square into 5. The next one would be 2 into 3 square into 5 square, and the fourth one will be 2 into 3 square into 5 cube. So I have 1 2 3 4. There are 4 factors that satisfy the given condition. Let's do this question. We need to find the number of factors of 27 factorial. Now remember, 27 factorial is nothing but 27 into 26 into 25 etc. up to 1. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. To solve this question, first we need to find all the prime numbers that are less than 27, right? Now basically we need to prime factorize 27 factorial. If we can do that, then we know how to find the number of factors, right? It's a straightforward thing. The challenge in this question is we should be able to quickly prime factorize 27 factorial. All right, let's do that. Let's find first all the prime numbers that are less than or equal to 27. So the prime numbers less than equal to 27 are 2, 3, 5, 7, 11, 13, 17, 19 and 23, right? These are all the prime numbers that are less than equal to 27. Now we need to find how many 2's are there in 27 factorial, how many 3's are there in 27 factorial, etc. Because at the end we are trying to prime factorize 27 factorial, and when you do that, when you do the prime factorization of 27 factorial, you will get something like this: 2 to the power a into 3 to the power b into 5 to the power c into 7 to the power d, etc. Each of these prime numbers will come over here till 23 to the power whatever x, right? And we need to find these numbers. If we can find that, we can easily find the number of factors of 27 factorial. All right, let's move on. Let me make some space over here and let's try to prime factorize 27 factorial. All right, now we start with the number of 2's. If I want to find the number of 2's in 27 factorial, the way is we need to successively divide 27 with 2, right? So 27 divided by 2 gives me 13. I just take the quotient, I ignore the remainder. 13 by 2 gives me a quotient of 6. 6 by 2 gives me a quotient of 3. 3 by 2 gives me a quotient of 1. Now I need to add these numbers: 13 plus 6 plus 3 plus 1, which is equal to 23. Therefore, in 27 factorial, the highest power of 2 that I can take out is 23, or 2 to the power 23 will perfectly divide 27 factorial, right? We have seen that before. So 27 factorial divided by 2 to the power 23 will give you a remainder of 0. It will perfectly divide it. All right, now let's move on. Let's find the number of 3's in 27 factorial. That would be 27 by 3, it gives me 9. 9 by 3 is equal to 3. 3 by 3 is equal to 1. So I stop over here because 1 by 3 gives me a quotient of 0. And I have to add these values: 9 plus 3 plus 1, which is equal to 13. So the highest power of 3 in 27 factorial is 13. Now let's do that for 5. So 27 by 5 gives me 5 as the quotient. 5 by 5 gives me a quotient of 1. Therefore, the highest power of 5 in 27 factorial is 6. Similarly, in the case of 7, 27 by 7 is equal to 3, and 3 by 7 gives me a quotient of 0. So I stop over here. The highest power of 7 in 27 factorial is 3. All right, let's go on. Similarly, you will see that in the case of 11, 27 divided by 11 is just 2, and you have to stop over here. So the highest power of 11 in 27 factorial is 2. Similarly, you can find out the highest power of 13 will be 2, 17 will be 1, 19 will be 1, and 23 will be 1. So these are the highest power of these prime numbers that are there in 27 factorial. All right, let's keep that aside. Now, using this, we can write the prime factorization of 27 factorial as 2 to the power 23 into 3 to the power 13, right? You have 23 over here because you have 23 2's. You have 13 over here because you have 13 3's. And into 5 to the power 6 because you have 6 over here. Into 7 to the power 3, right? Into 11 to the power 2. Into 13 to the power 2. Into 17 to the power 1. Into 19 to the power 1. Into 23 to the power 1. Now, because we have the prime factorized form of 27 factorial, we can directly write that the number of factors of 27 factorial is equal to 23 plus 1 gives me 24, 13 plus 1 is 14, 6 plus 1 is 7, 3 plus 1 is 4, 2 plus 1 is 3, 2 plus 1 is 3, 1 plus 1 is 2, right? Over here you have 1 plus 1, that's 2. Over here also you get 2, and over here you also get 2. You just need to multiply all of these. That's equal to 24 into 14 into 7 into 4 into 3 into 3 into 2 into 2 into 2. So this is the answer. This is the number of factors that 27 factorial has.